This is Unit 0, Worksheet 5, number 8. A hammer is dropped from some height, pinching a piece of paper between its head and a large steel ball. An important thing about this one, I don't know if you noticed this from doing it or watching the video. After you hit this thing and you look at the hole that's in the piece of paper, the edges of that hole are singed, they're brown, and it smells like smoke. So what's happening there is you're actually creating enough of a temperature change to actually burn a hole through that paper with the hammer hitting the ball. And that burning, just like when you burn fuel in a car, like gasoline in a car, or when you burn your food to have fuel to move around, play games or whatever, then it's actually a chemical change. So what changes? The paper changes. Oh, I'm so sorry. What's in our system first? So in our system, we're going to have to include the hammer, the paper, the ball, probably the air, and the earth. All these things need to be in there so that we have an isolated system. Right? I can draw that out here so you can kind of see everything that we're including in there. And also I'm going to say, hey, when the hammer is here, that's going to be my zero reference level for the gravitational energy. So if you can see A, B, and C, you're slightly above the ZRL, and then at D, the hammer's finally at the ZRL. All right, so things that are changing. We talked already about the paper and how when the paper burns, that's going to be a chemical change. So that's going to be E-chem. If you look, the hammer goes from a high position to a low position, so that's the height of the hammer. And that's going to be associated with the change in the gravitational energy. These little arrows are telling me that the hammer is moving faster and faster and faster and comes to a stop, which tells me that the speed is changing. And that's change in speed is associated with a change in the kinetic energy storage of the system. And finally, the temperature is going to change. Again, we talked about how the paper gets so hot that it burns. And so that's going to be our thermal energy account. Okay, so I'm going to go ahead and get my bar graphs ready. E-chem, E-G, E-K, E-therm. Okay, and now we'll go ahead and start copying these things. Try not to erase it this time. There we go. And now we start. Well, we're going to have E-chem in the system at the start with the paper. And then if you think about when does that chemical energy go away, it goes away in that very last snapshot there at D. So at D, we're going to take that E-chem and have it go away. We're also going to have gravitational energy, and the height of the hammer is changing, so I'm going to work backwards here. At D, you're at the lowest point, so there's no gravitational energy. At C, you're a little bit higher than that, so I'm going to put one block at C. B, you're a little bit higher than that, so I'm going to put two blocks at B. And at A, I'm a little bit higher than that, so I'm going to put 3 blocks at A. Okay. Let's see here. At A, if at A the object is not moving, right? At A the object is not moving, so that means the kinetic energy is going to be 0. And at A, the thermal energy account is equal to, the 0 energy stored in the thermal energy account, because we're going to say that the temperature of our system at A is going to be as low as it's going to get at A. And so really 1, 2, 3, 4 blocks of energy is all we've got to work with. Okay, so at A we've got 4 blocks of energy. That's great. At B, we've only got 3 blocks of energy. So I must have 1 block somewhere, and if you take a look here, at B you're moving, so the kinetic energy must be that extra 1 block, or you think of the fact that it went from 0 to something. That something is the 1 block of kinetic energy. The speed went from 0 to something, so that means that the energy stored as kinetic energy in the system went from 0 to something. And then if we look at the fact that we had 3 blocks here, I need to add one more to get to the 4 blocks that we have here. All right, so that's kind of what I was thinking as I went through and drew those blocks. At C again, we're going fast, right? At C, it's going faster than B, which means the kinetic energy account must have more energy stored in it. What's bigger than 2? Nope, sorry, I can't read. What's bigger than 1, right? What's bigger than 1? How about 2? But then you have to look and see if does it work, right? Does that work with the total amount of energy that we're allowed to have in the system? And I think you can see that it does. We got 4 blocks at A, 4 blocks at B, 4 blocks at C. And finally, you look at D. At D, your object is standing still. That's what this dot is all about there, right? The object is at the ZRL, so there's no gravitational energy. And now the paper has burned, so there's no chemical energy either, which means that all of our energy now must be stored in that thermal energy account. And that's all of our energy. When I say all of our energy, I mean the 4 blocks, the original 4 blocks that we had at A, is now in the thermal energy account.